Right. So just hang on a second. Right. So sorry. Right. So quick recap of the method of components that we discussed last time. So we saw that with respect to an xy plane, if we have a vector that looks something like this, or in terms of geometry, the vector has a magnitude, let's say capital A, and makes an angle theta, then we draw perpendiculars on the x and y axis, and the so-called projections that the vector throws on the x and y axis, those projections become the so-called x and y components, which in scalar form we can write as ax and ay, but in vector form we write the components as ax I cap and ay j cap. So ax and ay here are scalar quantities. I cap and j cap are the unit vectors along the x axis and the positive y axis. So ax I cap becomes a vector of magnitude ax along the x axis, and similarly ay j cap. So we add these two vectors, you can see you get the original vector. So this is the vector expressed in component form. Okay. And the two conversion equations are, suppose we know the magnitude of the vector and we know the angle theta, and we want to find out ax and ay. So we use the formula ax is a cos theta and ay is a sin theta. Okay. And suppose on the other hand we know ax and ay, the components are known, and we want to find the magnitude of the vector and we want to find the angle theta. Okay. In that case, there is a I cap in question number, yeah, there is. Okay. So I'll be discussing the questions moment. Okay. So in that case, E becomes, the magnitude of the vector becomes square root of ax square plus ey square, and the angle theta becomes such that tan theta is equal to ey by x. So it's a very simple thing really, especially when you look at the vector in the first quadrant. It's just, you know, Pythagoras theorem or simple trigonometry application. The complication comes in when you are including four quadrants, because the vectors could be making any kind of angle. The angle could be in second quadrant and the third quadrant also. Okay, so like that. So not to worry about that immediately. So let's look at a quick set of examples. So I will start with the example from the worksheet. Okay, and then of course before that, before the examples, we had also seen how to add and subtract vectors. Okay, so if the vector A and B are given in terms of component form, then the addition of the two vectors becomes the sum of the x components. Sorry. I mean, first step is you could write it this way, but it becomes sum of A's x component plus B's x component into I cap, plus sum of A's y component plus B's y component into the whole thing into j cap. And similarly, if for some reason we are subtracting the two vectors, okay, then this here becomes minus and this here becomes minus. So this is like a common formula that you can see with just the sign interchange that we can use for addition and subtraction. Okay. So yeah, at somebody's request, I'm just scrolling up and just doing the whole thing once. Okay. So this is the basic idea. So the x component is a cos theta, the y component is a sin theta. So this length over here, this perpendicular length over here, this is nothing but ay, and this horizontal length over here, this is nothing but ax. So when we write it in component form, this vector A is the sum of ax I cap plus ay j cap. So this was the basic thing. Okay, so now let us and then the addition of two vectors, or we can do the addition of more than two vectors also like that. Okay, So let's see some of the questions from the worksheet which are directly based on this idea. Okay. Or in fact, you know what, before the worksheet, I just want people to quickly write out or work out a question for you. We'll come to the worksheet, but let's do the practice of writing out components with this example. So I'm just giving you some examples of vectors. And I want you to quickly tell me the vectors formula in component form. So the vector E is like this. It has, let's say, a magnitude of 20, and this angle here is 30 degrees. Okay. Then another vector B, suppose like this, and for that, this angle is given to me. The angle it's making with the y-axis is given to me as 37 degrees, and its magnitude is 25. Okay. And the third vector I'm giving to you is going to be in slightly different way. Okay, so the third vector is going to be like this. Is pointing in this direction. That vector is C, let us say, where this angle is 30 degrees and its magnitude is, let us say, 16. So I want you to find the vectors A, B, and C, or express the vectors A, B, and C in component form. This is the x-axis, this is the y-axis. So very quickly, just tell me what is the express vectors E, B, and C in what we call component, okay, or notation, or you can also call this I cap j cap form. Express the vector in I cap j cap form, and then find the value, find the magnitude of the vector A plus B minus C. Okay. So also find me the magnitude of this vector. So quickly, let's just work this out, and that should be a good sort of warm-up exercise to just quickly recall the concepts that you've been using all of this week. Very good, Aditya Singh, that's correct. B you have to work out. That's also correct. Meg, that's correct. So you can see here the vector E is fairly obvious. It's in the first quadrant itself, so we don't need to do much. So its magnitude is 20 and this angle is 30 degrees. So we can see that the x component of A is simply E cos 30. That is 10 root 3, because cos 30 is root 3 by 2. And magnitude of the y component is E sin 30. So that is 20 into half, so that is just 10. So the vector E in component form very simply is 10 root 3 I cap plus 10 j. Okay. And in a question like this, there should be no doubt at the end of the day, because you can just cross verify yourself. Does this data agree with what the diagram is showing? So the magnitude of the vector is how much? Square root of 10 root 3 ka whole square, that's 300, plus 10 ka whole square, which is 100. So it's square root of 400, which is 20. So that's fine. And tan theta is this divided by this, so 1 by root 3, so that's 30 degrees. So there's no difficulty at all. Okay. Now in the same diagram, let me quickly show you the vector V also. It's again comparatively easy. The vector V is, let's say, something like this. It's not exactly perpendicular. This angle, this whole angle will be a little more than 90. and its magnitude are given as 15. So now the thing that you have to understand is that the total angle that the vector B is making, this angle, that is how much? This angle. For vector B, that theta, let's say for B, that theta for B is actually 90 plus 37 or 127 degrees. So don't make the mistake of taking theta for B as 53 degrees or 37 degrees. You have to take it properly, or you have to understand that it's in the second quadrant such that this angle is 53, so whatever. So now with that you can see for the vector B, Bx is B cos theta, which is 15 cos 127 degrees. Okay. Now you've done enough trigonometry to recall that this will become minus cos 53 degrees. Okay. So that is 15 into minus of 4 by 5. So that is minus magnitude of it, sorry, was 25, my mistake. So just make a quick correction here. So this should be 25. So this will finally become 20. So 25 the magnitude, 25 is the magnitude. So 25 into 4 by 5 as you know is 20, but here it will come with a minus sign. Whereas the y component is b sine theta. Now recall in second quadrant sign is positive. So as you can see in the diagram also, the y component of b will be along the positive y axis. So this is sine 53, or you can write it as plus sine 53 also, whatever. So it is 25 into 3 by 5. So it is positive of 15. Okay. So now b as a vector becomes minus 20 I cap plus 15. So that's vector b done for us. All right. Anybody come up with C as yet? Let me check in the. Yeah. So just note this down if you haven't, and try to work out the vector C in the meantime. If you have finished this. Yes, Piyush, to answer your question, when we come to three-dimensional components, which we will come to at the end of the day today, we will discuss about the unit vector along the z-axis, which is called k cap. But so far, we have restricted ourselves to two-dimensional vectors. Let me just check your answers. Yes, Vashant, sorry, Vashist, my mistake. Vashist, you are correct. Sanya, you are correct. Very good. Palak, I haven't got your answer yet. Have you sent me your answer before, Palak? Yeah, yeah. No, Palak, you have to also give the y component and check out the sign properly. Vashist, I will check your answer. Seems correct. All right, all right. Yes, Smita, I will wait. So I'm just giving you a perspective of the vector C again, that you are clear about that. thing you have to be mindful over here of people is that even though the vector C is drawn in the fourth quadrant, make sure that you understood what the angle is. Doesn't necessarily mean that the angle is in the fourth quadrant. Okay? The vector C is drawn like this, but what is its line of action? Its line of action is this one. No? This is the direction it's pointing. It's not pointing in this direction. It's pointing in this direction. Okay? It's not pointing in this direction. So that means its angle is in which quadrant? Second quadrant. So you have to be careful about that. So this angle is 30 and C's magnitude was 16 or something like that. Srishti is correct. Archit, your direction. This is the point I'm just making. Just look at my diagram and you'll understand. Okay. And even you, Piyush, you look at my diagram. Palak, your answer is correct. Okay. You look at my diagram and you'll understand. C का direction कैसे point कर रहा है? ऐसे point कर रहा है. Okay. So what you can even do to make life easier here is that you can pick up the vector C and just place it at the origin so that there's no confusion about its direction. When you place it at the origin, like this, it becomes even more clear that the direction of C is in fact this. So the angle that C is making, this angle was 30. So here this angle is 30. So the angle with the x-axis for C is actually 150 degrees because this angle is equal to this angle which is 30. Okay. And the magnitude of C is of course 16. So the vector C will have an x component of 16 cos 150. So that is 16 into minus cos 30. So that will become minus 8 root 3. Okay, that's the x component. And similarly, the y component is C sine theta. So that is 16 sine 150. Now you know second quadrant sine is positive. So it becomes sine 30, which is half. So it becomes 8. So the vector C actually has a negative x component and a positive y component. Okay, so now we've got all three vectors. Right, so most of you got this right, including Srishti, Piyush, Palak, everybody. Okay, good. So the vector E plus B minus C, I want to find that now. So just quickly recall the vector E was, sorry, E was 10 root 3 I cap plus 10 j, right? That is what we had calculated the vector is. And the vector B was minus 20 and plus 15. And the vector B was minus 20 I cap plus 15 j. So now these two have to be added and this has to be subtracted. So the vector E plus B minus C will become, take the x component of E, so that is 10 root 3. To that add the x component of B, which is minus 20 by the way. Don't forget that there's a minus sign involved. Okay. Then the vector C similarly had an x component which is negative. So minus 8 root 3. The whole thing into I cap. Plus again A plus B minus C. So A's y component is 10. B's y component is 15. And C's y component is 8. So this is the vector. So the vector of A plus B minus C is becoming 10 root 3 minus 8 root 3. So that's 2 root 3 minus 20. So minus 2 root 3, you can take minus sign common. Then you can take taken 2 common, doesn't matter. Plus this is becoming how much? 25 plus 8. So that is 33. So this is a vector A plus B minus C. Alright. And from that you can see that the magnitude of the vector A plus B minus C is square root of whatever this vector's x component is. So that is 2 root 3 plus 20 whole square plus whatever the y component is whole square. And then it's just a matter of algebra. So I'm not thinking of this, whatever this is. So this is the magnitude of the vector A plus B minus C. So hope this is clear to all of you people. Oh, sorry, my mistake. Yes, you're correct. Here there should be a minus sign because we are subtracting the vector C. Na? So it is A plus B minus C. So here this should come with a minus sign. And here also there should be a minus sign. So just make a quick correction here. So this will become, so these values will become 10 root 3 minus of minus 8 root 3. So that is 18 root 3. And this will become 10 plus 15, 25 minus 8. Okay. So 25 minus 8 will give us 17. Okay. So anyway, that will be your final answer. Okay. 18 root 3. So I've taken the minus sign common. Yes. Oh, okay. Yes. I can just write this over here. Okay. So this is finally becoming how much? This is becoming 10 root 3 plus 8 root 3. So that is 18 root 3 minus 20 I can. And this is 10 plus 15 minus, okay, that's fine. So this is 18 root 3 minus 20. Yeah. See, it is this because it is A plus B minus C. So what we have to do here is we have to do like this. For this value, we have to do AX plus BX, but minus of CX. Okay, I can. Similarly, AY plus BY minus of CY. Because on this side we are doing plus minus. So AX is 10 root 3, BX is minus 20, but CX is minus 8 root 3. Okay. So I'm just minimizing this for you people to quickly go through. Oh, okay, people. There is another set of errors here. Let me bring you up to speed here. So let us quickly look at the vector B again. Okay, so we got the angle correct. It is 127. So this is minus cos 53, but cos 53 is not 4 by 5. Cos 53 is 3 by 5. So this will become minus 15. Okay, and sine 53 is in fact 4 by 5. So this will become plus 20. So we'll have to make a correction in our B also. So B is minus 15 I cap plus 20 j cap. Okay. So let's take it easy. Let's first understand all the vectors. So I think A is clear to all of us. Okay, A is making an angle 30. So cos 30 is root 3 by 2. Sine 30 is half. So these values are correct. Okay. Then let us look at B again. So B in the diagram above. Okay. This angle was 37. So the angle with the x-axis, as we saw, is 127, 90 plus 37. So cos 127 becomes minus cos 53. The only thing is cos 53 is 3 by 5, not 4 by 5. So it is this. Okay. Similarly, sine 53 is 4 by 5. So the components of B are in fact minus 15 and plus 20. Okay. So these are the components. Okay. All right. Now let us come to C. Now look at the vector C in the original diagram. Okay. In the original diagram, the vector C is pointing like this. So immediately you can see C as a negative x component and a positive y component. So for that reason, what we have done is to understand the vector C, we have repositioned the vector C. Instead of placing it here, we have kept the vector the same, but we have kept it from the origin. So the moment you kept it from the origin, you can see that this angle is 30. So the angle C is making with the x-axis is in fact 150 degrees. It's in the second quadrant. So C's components become cos 150, okay, which is minus cos 30. So that is minus 8 root 3, and sine 120, which sine 150, which is plus of sine 30. So that is plus half. So C's components are correct. Okay. So let us, for the moment, keep it up to here. Then we are coming to the last part. Okay. I'm coming to the last part. We'll redo the last part. Okay, so I'll just give you people a minute here to once again go through the individual vectors A, B, and C. Make sure those are clear. So first A and B, okay. And then we have vector C. Vector C is a slightly tricky one because I had drawn it originally like this. Okay, so the thing is, whenever we draw a vector arbitrarily like this, just because it's in fourth quadrant doesn't mean that the angle is in fourth quadrant. So what we have to do here is properly draw the vector here. Then it becomes clear that what the angle is. Okay. So now let us come to the second part. So we got our vectors in the first part. Vector E was 10 root 3 I cap plus 10 j cap. Vector B with the correction we made is minus 15 I cap plus 20 j cap. And vector C, which was correct for us from the beginning, it is minus 8 root 3 I cap plus 8j. So now let's come to the second part. Now in the second part, what we want to do is we want to calculate this new vector. We want to calculate the magnitude of the vector A plus B minus C. Okay. So we can first just calculate the vector A plus B minus C. The vector A plus B minus of C will be just do the same operation with the components. So it is AX plus of BX minus of CX. And then again AY plus of BY minus CY. Okay. So now we just import the values from above. So AX is 10 root 3. plus bx. Now bx is a negative quantity, so it's minus 15, but minus of cx, and cx itself is a negative quantity, so that minus minus will become plus. So this whole thing becomes ax plus bx minus cx. Okay. And then similarly, ey is 10, by is 20, and cy is 8. So it becomes this. All right, so this becomes a vector. So hope this is all right now. Okay. Right. All right. So all these parts are clear now. Okay. So now let's work this out. So the x component is becoming 10 root 3 minus 15 plus 8 root 3. So that is 18 root 3 minus 15 I cap. Okay. And the y component is becoming 10 plus 20 minus 8. So that is becoming 22. Okay. So interestingly, we are still not done with the question, because now what we have found is the vector quantity, which is a plus b minus c. Now still one thing pending for us is we have to find the magnitude of this. Okay. So as we have seen earlier, the magnitude of any vector is the square root of the sum of the components. Square root of the sum of the squares of x and y. So this, and then whatever you calculate this becomes a final. Okay, so hope this is clear. All right, now just turn to your worksheet. We will work out some of the questions there now. So turning to the worksheet, so I will just go systematically with few of the questions. So for example, question 1, just for reference we'll do. So vector A and B were given and you have to find magnitude of A plus B. So vector A was just given as 2 I cap plus 2 j cap, and vector B was given as I cap plus 2 j cap. Now we wanted to find out magnitude of A plus B. So first of all, A plus B, very simply here, this becomes the sum of the x components, so that is 2 plus 1 I cap plus the sum of the y components. Yes, very good, that's correct. 2 plus 2 j cap. Okay, so that is 3 I cap plus 4 j cap. So this is the vector A plus B. Now I want to find the magnitude of this vector. So let us say this is what we call the resultant of vector A plus B. So magnitude of that resultant, nothing but mod of A plus B, is nothing but magnitude of this vector. So it is square root of 3 square plus 4 square. So very simple. All of you know that is 5. That is why the answer to this was 5. And similarly, the second question was connected to this. You have to find out the angle, okay, theta of A plus B with respect to the x-axis. So that angle is given by the simple formula, yes, that tan theta is equal to y component divided by x component. So in this case, the y component is 4 and the x component is 3. So you know that when tan theta is 4 by 3, theta is equal to 53. So that's it. So this becomes this question. Now similarly, the third question is just like the question we did. So I am not getting fully into it. The vector was given to you. Now only thing is if there is confusion about the angle in third question, then do just one thing, that redraw the vector from the origin. Okay. I'm just giving you that as a hint. So now in this vector was drawn like this somewhere. And this angle was shown as 30 degrees. Okay. So you can see over here itself that the angle it is making with the positive x-axis is this, it's 120. Okay. So that is the proper value you should use. Okay. However, if you are getting confused in the diagram of the question, then you can always do this. You can just shift your vector from here to here. Just draw it from the origin. That is 100% clarity. Okay. And then you can see that because this angle is 30, it means that this angle is 120. So for the vector E, the theta is 120. Okay. So again, cos theta will become minus cos 60. Minus half. And sin theta will be plus root 3 by 2. So use these values and you will be able to do question number 3. Now similarly, fourth is the type of question where some of you might have, who have read ahead, you might have done by using products, but I don't want you to do with products right now. I want you to solve this question just by using the the simple method of the geometry of a vector which I have taught you. Okay. So in fourth question, one vector is given to us like this. It is 12 I cap plus 16 j cap. So first thing you do is find out what is the angle E is making with the x-axis, and you'll see that it is 53 degrees. Is this clear to all of you? Why it's 53 degrees? Because we are just using the formula tan theta is ay by ax. So ay is 16, ax is 12. So tan theta is 4 by 3. So that means the vector E is like this. Okay. Now similarly, now vector B is given to you. Now for vector B, the angle is a little bit more tricky because the vector B has one negative component. It is minus 8 I cap plus 6 j cap. So what is the angle that vector B is making with the x-axis? So let's look at this. So instead of getting into so much trigonometry and all that, what we can just simply do here is just visualize how vector B is looking. So vector B, you realize, has to look like this. It has to have a negative x component and a positive y component. That means it has to look like this. That's the only way it's possible that vector B has this component as minus 8 and this component as plus 6. Okay. Now you can figure out from trigonometry that this side is 6 and this side is 8. That means this angle is how much? It is 37 degrees. So what angle it is making with the x-axis? It is making an angle of 153 degrees. So the angle that vector B is making is 143 degrees. 90 minus 37. So it is 143. Okay. So this also I know. Now in the same diagram, if you just place the vector E, that you already knew. It's somewhere here. The vector E is like this. For E, this angle is 37. So now you can see you want to find out this angle. This angle theta you want to find out. So that angle theta is just the angle of B minus the angle of A, which is 90 degrees. Now later we will see that this is not the most efficient way of finding the angle between two vectors. There is a shortcut method, but from what I have taught you till date, this is the method I wanted you to apply for this. Okay. So this was question number 4. Now similarly, question 5 is comparatively easy. Okay, so I'll just tell you the method. So in question 5, what is happening is the force F1 is given to me. The force F2 is also given to me in component form. Whereas force F3 is known, is unknown. Okay. But there is an additional data given to me that if the 3 forces act simultaneously on a body, okay, then the resultant is 0. It says the sum of the 3 forces F1 plus F2 plus F3 is equal to 0. So this is what we do to find out F3. So what we do from here is that we realize that the vector F3 is negative of the vector F1 plus F2. Now whatever we know over here in component form, we just substitute that over here. So if you substitute that information here, you will get the value of F3 as a vector. And then you can find out its magnitude using square root of x square plus y square. So that was question 5. And from what I can gauge from the doubts people have been asking me, question 5 is clear to most of you, so it should be pretty clear. Now 6, 7 was a slightly, I wouldn't say tricky, but it was a manipulative kind of question. So I'll explain. So hope this is clear to all of you. So the thing is, yeah, the question especially which I'm leaving out for you still to do by giving a hint. If you haven't done it and verified the answer, then please do it within the next 1 or 2 days at least, today, tomorrow. Okay. And if you are still not able to get the answer for some reason or something, make sure that you discuss with me. You can send me a WhatsApp with a question number, or you can even send me a question WhatsApp with a question number and a small clip or photograph of the solution that you worked out in your notebook. That way I can even point out where you're going right or where you're going wrong. In case some step has gone wrong, some mistake has been made, I can point it out to you. So please do that, because that will ensure that your learning is 100%. All right, so now let's come to the question 6 and 7. They are connected. Yeah, question number 5 which is like this, that it's given to me that their sum is 0. F1 plus F2 plus F3 is 0. That means F3 is minus of the sum of F1 and F2. And now F1 and F2 के components दिए हुए हैं. So substitute the components here. You can find out what this bracket is. Okay. So just work it out. So from that you'll see. So you will see that the vector F3 will be minus of F1 plus F2, and F1 plus F2 will actually become 4i cap minus 3j cap. So its magnitude is 5 only. There's no difficulty with that. Okay. Just put the components of F1 and F2 algebraically in this. You will get the answer. Okay. If you're still not getting, do it later and send me the working. I'll show you where you're making the mistake. Okay. Now for 6 and 7 we have the same data. Okay. So we have that the vector A plus another vector B happens to be 10i cap. That means it does not have a y component. This has along the x-axis. And also given to me that the vector A minus B does not have an x component. It has only a y component, and that y component is 10 root 3 j cap. So this information is given to me. Now from this I have to find out the vector A or its magnitude or whatever, the vector B, its magnitude or whatever. These kind of things I have to find out. So you have to find out the magnitude of A in 6 and the magnitude of B in 7. So there's a little trick here. If you think of this like equation 1 and this is equation 2, you can see that one equation is the sum of 2 vectors, the other equation is the difference of 2 vectors. So if we just add the 2 equations, equation 1 plus 2 if you do, so you are having A plus B plus A minus B, having this now, so it becomes 2A on the left hand side. On the right hand side, you are doing the sum of these two. So it becomes how much? It becomes 10i cap plus 10 root 3. Okay. Now next step, what we can say that, okay, 2a. So hope this step is clear. What I've just done is added this left hand side with this left hand side. So a plus b plus of a minus b is nothing but 2a. The normal algebra. So next thing what I can say that, okay, if a is 2a is this much, then a must be half of this whole thing. which is nothing but now take the half inside like a distributive property. So A is 5 I cap plus 5 root 3. So the magnitude of vector A is just becoming square root of 5 square plus 5 root 3 whole square, which all of you know is 10. Okay, so that's it. It's as simple as that actually, nothing more than this. Okay, now note this down and I will give you the hint for doing the 7th part, how you will do in case you haven't got it still. I'll give you the hint of how you can use the same kind of information and get the 7th part where you have to find magnitude of B. So just like we added equation 1 and 2 to get 2A, like that we can subtract the two equations. Instead of doing equation 1 plus 2, we can do equation 1 minus 2 and that will give us 2B. Because it will be A plus B minus of A minus B. So A will cancel out and B and B will add and we'll get the value of 2B as a vector. And from that we can find out the magnitude of it. Okay, so that is how you are supposed to solve this question. You can do that also better. That's correct. That's correct. You can just substitute the value of A in either the first or second equation and you'll get the value of B. That also you can just substitute this vector A. Okay, substitute this in equation 1 or equation 2 and from that you find out the vector B. That's also equation. That's it. This as good a method. There's nothing wrong. That's correct. So anyway, what I will do now, just for convenience, because here it's easier. Next, I will do equation 1 minus equation 2. So I will get 2B is equal to 10 I cap minus 10 root 3J. Okay, correct. That's correct. So the vector B is interestingly working out to be 5 I cap minus 5 root 3J. So it's not the same as vector A, you can see. Vector A is different. It is 5 I cap plus 5 root 3. Vector B is minus 5 root 3. So they have different directions because they have different components. But interestingly, the magnitude of vector B is the same as the magnitude of vector A, which is 10. So A and B are having same magnitude, but please understand they are not the same vectors. They have different directions. If you draw the vectors A and B, you will understand they have different directions. A is a vector which is in the first quadrant somewhere because it has both components positive. B is a vector which has negative second the y component and positive x component. So B is a vector which is like this. But both of them are 10 in magnitude. Okay. And you can just continue this problem forward if you like and find the angle between the two vectors also. So that's just like an addition of the previous question like that. Alright, so that is question number 6 and 7 for you. Now probably the tricky question in this whole exercise, the most tricky one, which is question 8. Question 8 involves some manipulation of the algebraic equation. Okay, so let me explain how question 8 works. Alright, so I think this should be clear to all of you. Okay, so now question 8 firstly had a lot of statements given. So whenever you see a question like this, it looks a little scary. So the first thing we should do is note down all the information given. So mod A is given to us as 5. That is one information given. Okay. Then it is given to us that C is equal to A plus twice of B. Okay. And C is perpendicular to A. So this additional information is given to us. Whereas now the third thing that is given to us, that the vector D is actually the resultant of A and B. And the magnitude of vector D is the same as magnitude of vector A, which is 5. So from all this information in question 8 and 9, and in fact 10, all three questions are related to this. We have to find magnitude of C, we have to find magnitude of B, and we have to find the angle between A and B. Theta between A and B. So, it's one thing that, till now in this worksheet we have been using component algebra. So you might think that, okay, you might have got used to using component algebra and you might go ahead with component algebra. So you can do that also, that's no problem. But just as an advice to you here, what will happen is that, see, if you notice the information that is given, it is given, some information is given as the sum of two vectors and there's a 90-degree angle. So that means if I were to draw the triangle and use triangle law, it would be something easy for me because it's a right angle triangle. And then again, some other information is given to me that the vector D, which is A plus B, that the magnitude of D is 5 and the magnitude of A also, you remember, is 5. So it is isosceles triangle. So even that triangle is comparatively easy to work out. Okay. So here I'm sort of getting a hint that because I have a 90-degree angle involved in the triangle C, which is A plus 2B, and because I have an isosceles angle involved in the triangle D, which is A plus B, I might have a benefit of using the geometrical method. So let's see if that works out for us. Okay. So let's go with the geometrical method first, where I assume that this is the vector A. And let me now interpret the statement first one, that the vector C is the sum of, so B I don't know what it is like. Okay. So B I have no idea about right now, but A, suppose I assume the direction is like this and its magnitude is 5. Now what is the information about C? So let us use that information. So the information about C is that the vector C is perpendicular to A plus 2B. So if this is my vector A, which is of magnitude 5, then the vector C must be perpendicular to this. So the vector C must be something like this. I don't know how much its magnitude is, but I know that the vector C is at 90 degrees to E. It is either 90 degrees and above like this, or it could be 90 degrees and below. So let me assume like this. Now C is coming from what? It is coming from the sum of A and 2B. So that means in this diagram, where is the vector 2B lying? It's lying over here. This must be the vector 2B, which kind of gives away the fact that the angle between A and B has to be obtuse. Whatever this angle theta is, we know that it has to be obtuse. So this is the information that we have from the fact that C is equal to A plus 2B. Okay. And C is perpendicular to the vector T. This is the information we have. How we got to B? We haven't got to B beta yet. What we are just doing is we are using the statement, okay, that C is equal to A plus 2B. So this is just the statement of triangle law. So statement of triangle law is if we have one vector A like this and another vector 2B like this, then this must be the vector C, which is A plus 2B. Okay. So here this vector C is perpendicular. So the vector 2B must be here. That is the information that we use. Okay. Yeah, I haven't used the statement about D yet. Okay, so that is what. So I just got this thing. Okay. I don't know the magnitude of C. I just know that this angle is 90. Okay. So here I can make use of the 90-degree thing over here. So whatever the magnitude of C, you can see that this angle is 90 degree. So A square plus C square should be equal to 2B whole square. That is the right angle triangle. That's one thing I have. And I have that, okay, sine theta Or in this diagram, you can see like this. If this angle is some alpha, suppose, okay, so tan alpha is C by A, or tan alpha is the same thing as tan of 180 minus theta. Okay, but it is better here that we involve A and B. Okay, so rather than this, what I would say is that, okay, cos alpha, which is minus cos theta, okay, because it's like this, okay, is equal to A by 2B. So that way, what happens is one thing is known in this, A's value is known. So we know cos alpha in this triangle should be equal to 5 by 2B. So that is the second information that I'm getting from this triangle. Okay, this is one information I'm getting, and this is the second information I'm getting. Now both the information are going to come useful for me, because see what I have to find out. I have to find theta, and theta in that diagram is what, 180 minus alpha. So if I can find out alpha, it will be useful. So I've got alpha as an unknown, and I have to eventually also find mod C and also find mod B. So all those things are there. Okay. C is unknown, B is unknown, alpha is unknown. But there are three unknowns, right, in this set of equations. C is unknown, B is unknown, and alpha is unknown, or theta is unknown. So two equations are not enough. So that is where just solving the triangle of D is of C is not going to help me. Alone it is not going to help me. Along with that, I have to also use the second information which I have not used so far, which is about which triangle, the D wala triangle, which is A plus B. Okay, so this is one information which I am getting from which part of the statement, about the vector C. Now similarly, I have to make use of the other information. I made use of this information now. This is done. So from this I have got those two equations, but those two equations have three unknowns. C is magnitude, B is magnitude, and the angle theta or angle alpha, whichever you're taking. Those three things are unknown. Now also make use of this information. So let's come to the second triangle. Let's look at that. So in the above triangle, we just make some adjustment. Now I have to do A plus B. Okay, so I have to do this. The D is equal to A plus B. This triangle I have to solve, where it is known to me that magnitude of D is equal to magnitude of A is equal to 5. This information is given that both D and A are having magnitude 5. So let's work this out. Okay, so if this was my vector A, if this was 5, then my vector B now will have to be something like this. Have to be like this, where this is the same angle as in the above triangle, but only this side is lesser. There it was 2B, here it is just B. So these two angles are same. Okay, so for a moment I'm just saying compare just this diagram with the diagram above, then I'll come to D. Don't worry about D in the triangle yet. Okay, just compare these two diagrams so far. Okay, what you'll notice in the above diagram we have 2B, and in this diagram we have B. So what they have in common, the vector 2B and the vector B, is that their direction. So both of them are making the same theta with A, or this interior angle is alpha for the same one. Okay, but this one has double the magnitude compared to this. Right. So hope this point is clear. So that is what is going to help us solve this slightly tricky question now. Okay. So coming back to this now, in this we now have the third side, which is the vector D. This is the sum of A and B, which is this one. This vector is D, and it's given to me that this side is also 5. Okay, so here unfortunately there is no right angle triangle or anything. It is an isosceles triangle, but better than that is to use this thing, that if the vector D is equal to the vector A plus B, that means D's magnitude is equal to root of A square plus B square plus 2AB cos theta. see, when I substitute in this equation now, D is known, A is known. So I'll have another equation and only those two unknowns, B and theta. And theta will come in terms of alpha. So I'll get my third equation in terms of the variables that I'm looking for. So substitute here, D's magnitude is 5, A's magnitude is 5, B's magnitude is the unknown quantity. So it is 10B cos theta. And you can see that cos theta here is minus cos alpha, because theta is 180 minus alpha. So I can also substitute this as minus cos alpha. So I have the equation that 5 is equal to square root of 25 plus b square minus 10b cos alpha. Or what I can do is I can square both the sides, which will be even nicer. So squaring both the sides, 25 is equal to 25 plus b square minus 10b cos alpha. Now you see this is giving me something really useful, because the 25 is also cancelling out on both the sides, and it is giving me that b square minus 10b cos alpha is equal to 0, or factorize this. Okay. So obviously b can't be 0, so the bracket must be 0. So that implies that b is equal to 10 cos alpha. Because b is equal to 0 is not possible. Okay. So I'll just minimize this a little bit for you to understand how we have converted this information about that triangle into an equation from triangle law of vector addition. So from the second statement that the vector d, which is the sum of a plus b, is also of the magnitude 5. We don't know cos alpha directly. We know it in terms of b. So we'll put that now. Okay. So cos alpha we know is 5 by 2b. So when we put that, that's it. It's done. But no, so the first triangle solution gave us two equations, but it had three unknowns. Cos alpha was an unknown, b was an unknown, and c was an unknown. And the second equation now is, the second triangle is giving me my third equation, which has two of those same three variables. So now if you compare equation 1, 2, and 3, there is a system of equations of the same three variables. So three variables, three equations, we have got the solution. Now it's just a matter of working it out. So rest is just equation solving. Okay? But this is how we are using the information in the given problem. Okay. So I'll just once again take you through the first triangle also, so that you remember how the first two equations have come. So I've made use of this condition which was given to me for the first triangle, that C is the sum of A plus 2B, and C happens to be perpendicular to A. So if I draw that vector triangle, A plus 2B must give me a perpendicular sum, which is C. So that fact is giving me something from Pythagoras theorem, and that is giving me something from trigonometry. That if this angle is theta, then the interior one being alpha, cos alpha is based upon hypotenuse. So 5 by 2b. Okay. And later when we get the value of b, we'll put it in this equation. So that will give me the value of c, because e is known. And now I can see that two equations here, but three unknowns, c, b, and alpha. So I need some more information and some more equation, one more equation. So that comes from the second thing that is given to me. That if you consider the vector d, which is the sum of a plus b, it has the same magnitude as e. So that is giving me something from triangle law statement, which is the relation between v and alpha, which is this. Okay, so the same two vectors a and b are satisfying the condition of the above triangle, the triangle involving c, and they are also satisfying the situation of the second triangle, which involves the vector d. So by solving the two triangles, we will get the condition required. So now solving these three equations, you can see that. So now we substitute this in equation 2. So equation 2, if you go above, you'll see it was cos alpha is equal to 5 by 2b, because it was based upon hypotenuse. The base of that triangle was a, the hypotenuse was this. Okay. So now substitute this over here. So you can see from this, cos alpha can also be written as 10 by b. So b by 10. So substitute that over. Substitute this way. So b by 10 is equal to 5 by 2b, which means b square is equal to 25, which generally should mean that b is equal to plus minus 5, but here b will just be 5 because b is a magnitude of a vector. So it cannot be a negative quantity. It's a modulus quantity. So we won't take plus minus 5 over here. So that's it. Now I've got b. So once I've got b, so I also know cos alpha now. So cos alpha is 5 by 2b. So that is becoming half. That means alpha is how much? It is 60 degrees. Okay. But don't be fooled that alpha is not the angle between A and B. No, that would be wrong because you can see both the triangles that the angle between A and B is an obtuse angle. So it is pi minus alpha or 180 minus alpha. So theta, which is the angle between A and B, is 180 degrees minus alpha. So the correct answer for that part is 120. Okay. So that is done, and we also have to find the magnitude of C. Now C, remember, was square root of 2b ka whole square minus a square. This was my equation 1. Okay, this is from equation 1. So that will show you that C is equal to square root of 10 square minus 5 square. So I've got my 3 numbers. So that this latter half of this is just the solving of equation 1, 2, and 3. Okay, so that's not something which is so worrying over here. The main thing is how we made use of the conditions to solve two triangles. So this solves the series of questions 8, 9, 10. The answer keys for this exercise are all correct. I have double checked them myself. So in case you are not getting some answer after today also and solving it, please follow my advice. Okay, what would be best is you show me your working by just sending me a clip. Then I can exactly pinpoint where you have either made a mistake or something has been overlooked. And otherwise also you just tell me which question you are having difficulty with after listening to all this later today or tomorrow or whatever. But try to complete all this latest by day after tomorrow. Try to complete this portion. Anything remaining in, yeah, don't worry, products and all we are coming to. We have plenty of stuff left in vectors. Okay, vectors will run for another 3 weeks from here. Don't worry. Cross and dot products are two very specialized kind of operations in vectors we are going to see. So as of now, what I can tell you about them is that dot product is something that we use in things like work done by a force in physics. When we are calculating work done from force and displacement. Whereas cross product is something that we use in, don't worry about test syllabus. Test syllabus will be up to dot product and by then we will finish that. Okay? Next week we'll be finishing dot product and we will have one more week for full revision. Your test syllabus will not include cross product. At the end of today's lecture, I'll give you a list of the things which are going to come in the test. Okay. Torque is cross product. That is correct. Okay. Torque is an example of cross product. We'll also see something very interesting. You can also calculate the area of something like a parallelogram or a triangle using cross product. If you express two sides of it as vectors. Okay. What should I see to Tanish? Please be more specific. Okay. So this was about this question. There are two methods to solve addition surveys in general. Okay. Yeah, Aditya and Tanish and all too. I think Tanish is also referring to the test only when he says see to it. Sometimes I find these kind of questions a little difficult to understand. So please see to it, but it's fine. So I will explain the test syllabus. Don't worry about test syllabus just now. Okay, just concentrate on the vectors till we come to the end of the lecture. I'll explain to you. Okay, next thing we look at is question 11, 12 and 13. They were just based on this diagram, and this was actually again comparatively easier question. So I'm just giving you a hint of what you should do over here. You should just express the three vectors which are given in component form, and then just answer the questions. Now the only thing is that sometimes in questions like this, it is difficult to look at the values and answer which option is correct. So sometimes it's a better idea to check the options and see which option is correct. So just substitute the values of the vectors that you're getting in component form in each of the options and see, okay, option A is correct or not, option B is correct or not. That way would be easier rather than from the vectors try to calculate what is A plus B, A minus B, like that. Okay. So anyway, so let's start with each of these vectors. So vector E is given like this over here. It has a magnitude 10 and this angle is 60 degrees. So I'm just writing vector A directly, and you can just work it out yourself on the side. Cos 60, sin 60 using those values. So it will be 5 I cap plus 5 root 3 j cap. Okay. Am I correct? Just verify my solution. Okay. Then similarly, I'm directly showing vector B, and I'm going to write the vector. Okay. So vector B is like this, and this angle is 60. So that means the angle that vector B makes with the x-axis is 120, but its magnitude is also 10. So using cos 120 and sin 120, okay, I'm going to use directly that this is minus 5 I cap plus 5 root 3 j cap. I'm just giving you guys a few seconds to verify that are these two values correct. Just tell me are they correct or not. Vector C is just pointing along the x-axis, positive x-axis that way. So I can see that vector C is plus 10 I cap. Correct? Yes. You did, I think, you verified that's correct. Should be getting this right. Okay. Now you don't have to do anything else. You have to just check out the options. That's all. So for example, you can see question 11 is about two things, A plus B and A minus B. So just calculate them and see which options are correct. That's what I mean by saying, back calculate from the options. See what is given in the options and verify whether the options are correct or not. That's what I mean by this. Okay. So question 11 is about finding out A plus B and also some information about A minus B and then checking out which one is correct. Okay. So just do vector sum like here. So A plus B is 5 plus or minus 5. So 0 I cap. So that's nothing. Plus 5 plus, so that's 10 root 3 j cap. So it is just basically that 0 doesn't matter. It is 10 root 3 j cap. So this vector A plus B is like this. Is pointing along the positive y-axis, as you can see, and it has a magnitude of 10 root 3. Now anything we are asked, whether we are asked about the magnitude or the direction, we can answer. So in this case, you asked options about the magnitude, about the direction. You can see it is along plus j cap. Now similarly, the second one you can see A minus B. All you have to do is subtract the components. So the x component is becoming 5 minus of minus 5. So that will become 10, correct? And the y component will become 5 root 3 minus 5 root 3. So this time this component is 0. Okay. So it is basically just 10 I cap. So in comparison to this, A minus B is looking like this. It is along the x-axis, positive x-axis. And its magnitude is interestingly 10. As you can see, this is A minus B and this is A plus B. So just verify my solution, is this correct? And then you can just check the options of not only question 11, but now we'll get 12 and 13 also. And 14 also. 12, 13, 14, all three are this. So in 11th you can see that option B is correct. Magnitude of a plus b is 10 root 3. So it's asking which is incorrect. Okay. So option A is correct, option B is correct, and option C is wrong, whereas option D is again correct. So A, C and D are correct, but since the question is asking you to point out which option is wrong, which is the incorrect option, so the final answer of 11 will in fact become C, because that is the incorrect option. Okay, so hope that is also clear. That is why the answer is given as C and not EBD. Okay. Now 12th is the slightly tricky question. Okay, 12th is also fine because you have to just do addition. So 13th is the slightly tricky question. Oh, 11th is given as B, is it? So 11th, the answer should be C. Okay, so just make a correction. In 11th, the answer should be C. C is the incorrect option. Okay. Now let's come to 12th. So A plus B plus C. So just add the three vectors. So you can see the x component is 5 minus 5 plus 10. So that's 10. And the y component is 10 root 3. So this has a magnitude of 20. You can work it out. Root of x square plus y square, you will get the answer is 20. Right, so 12th is done. 13th is a bit tricky. And 13th is that type of question where I'm saying that you should actually go backwards. Check what the options are saying and see which one is correct. So which one of them is a null vector? So calculate each one of these. So for example, A minus B plus C. Is this a null vector? We have to find this out. So work this out. So A minus B from above you can see is just 10 I cap. Okay. And C is 10 I cap. Okay. Sorry, plus. So this is 20 I cap. It is not a null vector. You can see that it is not a null vector. A plus B, A minus B plus C is not in fact a null vector. But if you see option B, it is asking is, what is option B now? B minus A plus C. Now if you work this out, you will see that this will actually be Z. This will be a null vector. Because see, A minus B, we just saw, was 10 I cap. So B minus A is nothing but minus of A minus B. So that is minus 10 I cap. So this thing is minus 10 I cap, and C we can already see is 10 I cap. So if you add this with this, you have to get 0. So that is why this is. So this is correct. Okay. So this will not be the correct option because it's asking which is the null vector. Okay, so this is the wrong option. This is the right option. Okay. And similarly, C and D also you work out that way only. Okay, so C you see is A plus B minus C. Now if you go back up, you can see that A plus B was actually along the y-axis. It was 10 root 3 or whatever, j cap, and C is along the x-axis. So again, how it can be 0? It's a not a null vector. So the only one which was a null vector was this one, B. So the answer should be B. So hopefully the answer is B. Yes, the answer is B. Okay. Similarly, 14th is direct again. You have to see what angle the sum of A, B, and C is making with the x-axis. Okay. So A, B, and C you already got. A plus B plus C is this. You have to see its angle with the x-axis. So tan theta is y by x. So it's just root 3. So the angle is 60. Okay, so the angle should be 60. So again for 14th question, you have to analyze A plus B plus C only, which we already analyzed, but not for magnitude. You have to find the angle. So I'm just copy pasting A plus B plus C from above. It is 10 I cap plus 10 root 3 j cap. So you can see that tan theta is equal to root 3 and it's in quadrant 1. Because you can clearly see that this vector is having a positive x component of 10, a positive y component of 10 root 3. So the vector itself must be in the first quadrant. This is this resultant vector. So this angle we're talking. So this angle is 60 degrees. Okay, so whenever you are in doubt about the quadrant of the angle, first, second, or third, or fourth quadrant, in terms of the components given, one trick you can do is just quickly draw the vector with an xy axis perspective. So you'll understand very easily whether the angle should be acute or obtuse, or it should be between 270 and 360 for fourth quadrant, or even between 180 and 270 for third quadrant, like that. So these kind of things. All right. And likewise, 15th question is very easy. I'm leaving it out for you. You just write root of 5 square plus y square should be equal to 13. So you'll get the answer as 12. So hopefully through this worksheet, we have done a good bit of workout and exercise related to the application of all the principles we have learned today. Because don't forget, in this we have also used triangle law in one place. So we've done a revision of triangle law also through this. Okay. Now let us move ahead in vectors. So moving ahead in vectors. So hope this was clear to all of you. I'll just check the messages. Yes, this is a JEE level question service. In fact, these are the type of application. So just that change in answer key in 11th question, then I'll forward the change in the answer key. So that is it. Okay, now the next thing we will see in vectors is we will come back to geometry. Okay, so back to geometrical. Just hang on a second. I'll refresh the whiteboard software. It's gone a little slow. Okay. So back to geometry. Okay. And in geometry, we'll see some special theorems. Okay. So, you know what is happening now? Now that you're doing component algebra, you will be gradually realizing that generally speaking, you know, when you're looking at a numerical problem in vectors, some angles are given, some magnitudes are given, or vectors are directly given in component form. Typically, it is easier to use component algebra to work out the algebra, whether you're doing some difference or something hybrid like E plus B minus C, etc. It's always easier to use the component method. And not only that, very soon we are going to come to three-dimensional vectors. So there you'll see the only option you have is of using components. Okay. However, there are certain special type of cases where geometry comes very, very useful. And those will be expressed by these special theorems that we're going to discuss next. So the first of the special theorems actually we have already discussed, which is the triangle law for addition of vectors. But we'll look at a couple of more aspects of it. So when we look at the triangle law of vector addition, we saw that a vector A and a vector B like this. If the angle between them is acute, then the vector sum looks like this. So this is A plus B. Now the first thing that we look at here is compare this diagram with another generic diagram, okay, where the angle is obtuse, and see the comparison will show something very interesting. Suppose in both the diagrams I have considered vectors A and B to be same magnitude, more or less same magnitude, the same vector I have drawn here, but now I have just assumed that the angle between them is obtuse. So just analyzing the result here from the statement of triangle law gives us a very important aspect of vector algebra. Okay, so I'm coming to that. So the first thing that we'll note down as a special aspect of that theorem is that since the magnitude of A plus B is equal to root of A square plus B square plus 2AB cos theta. Now comparing the above two, you can see something very interesting here. We can divide this into three categories. If theta is acute, less than 90 degrees, then what happens? Cos theta is positive. We've already done a sort of question based on this. Cos theta is positive. That means what happens? The mod of A plus B is actually greater than a hypotenuse of A and B. It becomes greater than root of A square plus B square. So this is something useful to be mindful of. That whenever we look at two vectors, let's say their magnitude is 3 and 4. So root of A square plus B square is 5. So if the magnitude of the resultant is more than 5, it means that they must be having an acute angle. Because in this formula, cos theta must be a positive quantity. That's the only way this can happen. Okay? The condition for this to happen, that magnitude of A plus B is greater than root of A square plus B square, that means this quantity here must be positive. So when does that happen? When the angle is acute. Similarly, the middle case is, which I have not drawn in the diagram, what happens when theta is 90 degrees? So your cos theta is 0. So that is when the exact magnitude is the hypotenuse. So whenever we have this condition that A plus B's magnitude is root of A square plus B square, that means they are perpendicular vectors. And the third case is the second diagram that I have drawn above, that whenever theta is obtuse, greater than 90, and remember here I am talking about the angle between two vectors, so I am not going to third and fourth quadrant. It can only be between 0 and 180. So whenever it is an obtuse angle, as opposed to whenever it was an acute angle. So for acute angle, cos theta was positive. For obtuse angle, cos theta is negative. Okay. So if it is negative, then see what's happening in this formula. This is a negative quantity. So this whole thing inside the square root becomes less than A square plus B square. So that is when this thing happens, that our mod of A plus B becomes less than root of A square plus B square. Okay. So this is like a useful analysis theorem that we can develop from the statement of triangle law also, and also at some level you will understand this from geometry. If you just think geometrically, see what is happening. Suppose I kept my two vectors A and B at an angle of 90 degrees. In this case, then this thing here would have been the hypotenuse. Now from here, if I push it further like this side is actually becoming smaller. So that's why this is happening. Whereas if I push it on this side is actually stretching out. So that is why this is happening. Okay. So this has a very deep implication, that when is mod of A plus B greater than root of A square plus B square, when we are talking about an acute angle. When is it exactly equal to when we are talking about perpendicular vectors? And when it is less than root of A square plus B square, in fact that is happening when it is obtuse. Okay. So just make a note of this. This is like a special added theorem for your geometrical case. We'll see some of these theorems today, including another very interesting theorem called the parallelogram law of vector addition, which will help us sort out a lot of special cases of vector addition and all that. So this is the first point in the triangle law. It can be greater than the hypotenuse, it can be less than the hypotenuse, it can be equal to a hypotenuse, depending on whether the angle is acute, obtuse, or this thing. Exactly 90 degrees. Okay. Now the next question here is, if it is greater than root of a square plus b square, what is the maximum limit up to which you can go? So that's the next thing you see, that mod of a plus b being root of a square plus b square plus 2ab cos theta, that term. This term. Now see, when will this be maximum? When this term is maximum. And what is the maximum of this term? It is cos theta equal to 1 for theta equal to 0. Okay, so that's the next thing. Sometimes this is in fact called the triangle inequality. That means E plus B, its maximum possible value is corresponding to the case when cos theta is 1. And when cos theta becomes 1 or theta becomes 0, this actually becomes A plus B whole square. So it becomes magnitude of A plus magnitude of B. Okay. Or better stated, we can just write this like this: mod of A plus mod of B. This is the maximum possible case. Okay. And for this to happen, what should theta be? It should be 0. So they should be parallel vectors. So in general, we can say that mod of A plus B is always less than equal to, it cannot exceed this thing. It can become equal to this thing in the special case when theta is 0, and for all other thetas, it is less. So that's why this is sometimes called the triangle inequality. Okay. So those kind of things, I have a vector of magnitude 10, another vector of magnitude 6. What is the maximum possible magnitude of the sum? It's 16. No matter what I do to the two vectors of 10 and 6 in magnitude, I will never get a resultant whose magnitude of more than 16. If one force is 5 newtons, another force is 10 newtons, I cannot get a net force of more than 15 newtons out of them. And to get 15 also, what I have to do? I have to line up the two forces parallelly. Okay, so this is one thing. Now, similarly, on the other hand, we'll also talk about the minimum. So, left hand side of this equation, iska minimum kab hoga? Jab cos theta minimum hai. So now that you have understood trigonometry in all four quadrants, you have also understood here that mod of A plus B's minimum will correspond to root of A square plus B square minus 2AB. Okay, so this is the special case when cos theta is equal to minus 1. That is the minimum value of cos theta, and that happens for theta equal to 180 degrees. Okay. So that further tells you that the minimum magnitude of A plus B, इससे कम हो ही नहीं सकता है, no matter how we align them. So the minimum possible magnitude is nothing but E minus B, but its magnitude, because B can be greater than A, or better stated, it is mod A and mod B का difference. So this is the minimum possible value, and this minimum possible value occurs for theta equal to 180 degrees, or what we call anti-parallel vectors. Okay. So if we are making individual displacements of 5 kilometers and 3 kilometers, the sum of the displacements can never be less than 2. Even if we went opposite in the second case compared to the first case, it would be 2. It would be 5 minus 3. So two vectors of magnitude 5 and 3, they cannot give you a resultant of less than 2, just as they cannot give you a resultant of more than 8. Okay. So this is the maximum limit, this is the minimum limit. So in other words, we can say that magnitude of A plus B is always greater than equal to magnitude of A minus magnitude of B. Whereas at the same time, it's always less than equal to this. This less than equal. So these are important statements on their own. In general, mod of A plus B has an upper limit of mod A plus mod B. It has a lower limit of mod A minus B. So these two together, they are called the triangle inequality. Okay. So just make sure you do a quick analysis of this, and then we'll come to the next part of the theorem. So now that we are getting into more advanced type of problem solving, you'll see that these theorems help us understand questions a lot. When you look at a question, when you look at the options, and you're thinking, okay, what should I do? Should I apply component? Should I apply triangle? What sort of triangle? So the moment you have these sort of points at the back of your mind, they help you analyze a question very quickly. They help you size it up. Okay, from what direction I should attack the question now. That is the whole process of this. Okay, so just make a quick note of this, and we'll move on to the next part. Okay, people. So just keep a note of this, and when you are revising today's lecture, understand the logic of how these statements are come, and you will see how it starts getting factored into questions. It may not come directly, but as I told you, it will help you analyze questions. Okay? So that was about the first special theorem, okay, which is basically an extension of triangle law of vector addition. Now next we'll see another type of triangle law, which is triangle law you can think of this like a part 2 of triangle law, part B, for subtraction. Now abhi tak humne subtraction kaise kiya, we have just done it by component algebra, but now we'll also understand how we can use a modified form of triangle law or part B of triangle law for doing subtraction of two vectors. So if I have a vector C which is equal to a vector E minus a vector B. So how to do this? Okay. So again here I am assuming that vectors A and B are known. Okay. So is that same kind of format like we discussed earlier. So vector A is given to me, vector B is given to me. Just for sake of arbitrariness, I am drawing two vectors which are at an acute angle, but they could just as easily have been at an obtuse angle. So this angle is theta. The angle between the direction of the vector D, which is this, and the direction of B. So magnitude of A is known, magnitude of B is known, and theta is known. Now we have to find out the vector C, which is the difference of these two. That means we have to find both the magnitude and direction of the vector C. So how we approach this is now very different. We are not going to break B into components and just do simple component algebra. We are going to think of this geometrically. So geometrically, iska matlab kya hai? So we can say that C, which is A minus B, is the same thing as A added with the vector minus B. And this is how we are going to do the operation. So in fact, you'll remember long time back, I think in worksheet 1, or if I'm not mistaken, we have even done a question which is based on this. So the difference of the two vectors, A minus B, is the same thing as the sum of the vector A with the opposite of vector B. Okay. So we'll keep vector A the way it is, but vector B क्या था? Vector B ऐसा था. So minus of vector B कैसा हो जाएगा? It will become like this. This become equal and opposite. Anti-parallel but of same magnitude. So this is my vector minus B. So now what I have to do is take my original vector A. It was given to me like this, and add that vector, but with which one? This one, because I want to do this operation. Okay. So let's work out that geometrically. So I've just drawn my vector A from some origin. Okay. And then I want to do the operation A plus of minus B. So to the vector A, I'm adding which vector? Minus B. So I pick up that vector minus B from above and I just draw it to the head of it. So this is the vector minus B. Because the vector B was in this direction. So the vector minus B is opposite to that. And in that diagram, this angle was theta. So here this angle is theta. So now what is my vector C, which is the resultant of A and minus B? It is this vector. This vector is C. So my job now is to find the magnitude of this vector and find this angle. Let's say this angle is beta. So I want to find magnitude of the vector C and I want to find the angle beta. Okay, because the vector C only is defined as this. It is defined as the difference of vectors A and B. Okay. So we can do it this way also, that the exterior angle is actually 180 minus theta. So the two vectors that we are adding, we can just use triangle law only. Okay, so we can say that okay, we are doing this operation that C is equal to A plus of minus B. Okay. So that means magnitude of the vector C is equal to root of A square plus, or let me write this more formally now since we are doing it this way. So it is square root of mod A squared plus mod of minus B squared, okay, plus 2 times mod A into mod of minus B into cos of which angle? Cos of this angle, because the vector A and the vector minus B, they are like this. So this angle is 180 minus. So without dropping the perpendicular and getting into all that algebra, I'm actually making use of triangle law only of addition. But I'm understanding that I'm not adding A and B. I'm adding the vector A with minus B. So everywhere B is replaced with minus B. So the angle also is replaced with the angle, instead of the angle between A and B, it is the angle between A and minus B. This is in fact 180 minus B. Okay. And now you just use the trigonometry in 4 quadrants. So here, keep in mind that minus B का magnitude कितना होगा? B के magnitude के बराबर ही होगा. So they are just opposite in direction. So that is B. Okay. And cos of 180 minus theta, which we've learned number of times now, is minus cos theta. So make use of that, and we get this formula now. So just like we had a triangle law formula for this thing, the sum of 2 vectors. Now we have a B part of the triangle law formula, which is for the difference of 2 vectors, and it is given by square root of A square plus B square minus 2AB cos of theta. So this is the second part of triangle law. You can think of it like an auxiliary part of the first part, which was the sum of 2 vectors, because we are basically making use of that only. But क्या कर रहे हैं? Instead of adding the vectors A and B, we are adding the vectors A and minus B. Okay. So as you can see, I have not done any fundamental derivation here. I have not dropped any perpendicular and worked out the triangle and all that. All I have done is I have seen my original vectors A and B, then I have defined my difference as the sum of the vector A and minus B, And to that I've used the theorem that I already have. I already know how to add two vectors, so why I should sit and derive another theorem? Okay. But I'm just replacing the vector b in my sum theorem with the vector minus b. So correspondingly, there's an adjustment. The angle theta has to be replaced with its complement, or 180 minus theta. Okay, so I'll scroll down and take you to the final result also. Okay, so now next thing is to find that angle beta, which I will just do by the same method. I'm using the formula of theta only, but I was doing a plus b. Now I'm doing a minus b. No, it should not be plus beta. It should, why it should be minus is because see, the angle is 180 minus theta, na? So if the angle is 180 minus theta, you do it by component method also, and you will get the same. You write as b vector as b cos theta I cap plus b sin theta j cap, and do a minus b, you will get the magnitude as this. You can do it that way also. So you can take, your x-axis along where the vector is, and take b at an angle theta, and write them in component form. So the vector A is just magnitude into I cap. Vector B is b cos theta I cap plus b sin theta j cap. And then you use component algebra for this. So if you use component algebra and do A minus B, you will come to this. If you do A plus B, you will come to the earlier formula. So your triangle law, interestingly, can also be proved by component algebra. That's to understand it, that you can actually do a proof of the triangle law, both the forms now, part A for the sum and part B for the difference. But now I'm also interested in finding that angle. So for that angle, I'll use the formula that tan beta will now become b sin theta upon A minus b cos theta. So I'm leaving this as a formula for you to work out yourself. You'll find this very easy to work out, because again, you're doing the same thing. You're doing that triangle law addition kind of thing, but you're replacing the vector b with the vector minus b. So remember that sine of 180 minus theta is sine theta only. That's why the numerator has plus sine theta and not minus sine theta. Whereas cos of 180 minus theta is minus cos theta. So there we had the formula tan alpha was b sine theta upon a plus b cos theta. Here that formula becomes sine gets replaced with plus sine only, but cos gets replaced with minus cos. So it becomes this. Okay. So this is the corollary. So this is the angle beta. It is the angle that the difference, that is A minus B, is making with respect to the vector E. नहीं, component form में 180 minus theta से क्यों confuse कर रहे हो बेटा? Component form में तो B vector लिख रहे हो ना? So B vector is making an angle theta with the x-axis only. So it is B cos theta I cap plus B sin theta j cap. So component method I've shown you how to prove this. Okay, you just write your vector B as this, and then you find out A minus B from here. So write it in component form, whatever it is. So see, it is this minus this. So A minus B cos theta I cap, and 0 minus, so minus B sin theta j cap, and then just calculate the magnitude of it, and you will get this. When you work out the magnitude, finally you will get this term. Okay. So this, I hope is clear. Okay. Now, so this is the triangle of vector subtraction, and you can also see something interesting in this. In this, you can note the next point here, that if you compare the formula of triangle law for subtraction with the triangle law for addition, remember in A plus B, this sign was plus over here. So if you compare the two, you see that when cos theta is 0, the two become the same. Okay, so additionally, mod of A plus B can become equal to mod of A minus B only in a special case. And that is a special case where they are equal to root of A square plus B square, because theta is 90 degrees. So cos 90 is 0. Okay, so the condition for this thing to happen, so you can say that this happens only for perpendicular vectors. It doesn't happen for general vectors. The magnitude of the sum of two vectors is equal to the magnitude of the difference of the two vectors. That happens only in the case of perpendicular vectors, and that is when theta is 90 degrees. So if you go back to the worksheet 3, you will see that we have actually done an application of this, but using components. That question we had, that 8, 9, 10 wala series, it was an application of this only. Where A plus B was given to you, A minus B was given to you, and they were perpendicular. One was along the x-axis, one was along the y-axis. That can also be understood from this, and that is why their magnitudes were coming out to be the same. Okay, so this is, and the other thing is that again, if you see the difference of two vectors, इसका maximum value कब होगा? Now this time see, when you go back to the triangle law statement, cos theta is coming with a minus sign. So left hand side is maximum, when in the right hand side cos theta is minimum. So cos theta's minimum is how much? Minus 1. When it's minus 1, it actually becomes the sum. So the maximum value of mod A minus B is mod A plus mod B. Okay. So the difference is actually equal to the sum of magnitudes, but this happens when theta is equal to 180 degrees, or cos theta is minus 1, or anti-parallel vectors. So when two vectors are anti-parallel, their difference has the maximum magnitude, whereas the sum has the minimum magnitude. When two vectors are anti-parallel, A minus B has the maximum magnitude, whereas A plus B at that time has the minimum magnitude. And similarly, minimum के लिए उल्टा, A minus B का minimum value कब होगा? When is the difference minimum? It is when they are parallel vectors, and that time it becomes the difference of mod A minus mod B. So this happens when theta is equal to 0, or they are parallel vectors. Okay. So that is like an opposite kind of behavior. When they are parallel, the difference is minimum and the sum is maximum. When they are anti-parallel, the sum is minimum and the difference is maximum. So they are like inversions of each other. Okay. So this is another sort of special point from the theorem of triangle law. That is the condition. That's why equality sign is being written. Maximum value is equal to mod A plus mod B, but in this special condition when they are anti-parallel. Similarly, the minimum value of A minus B's magnitude is mod A minus mod B, But that happens when they are parallel vectors or theta is 0. So in the above equation that we've written, no, the triangle one, this one, the moment you put cos theta as 1, right, you come to the minimum case. The moment you put cos theta as -1, you come to the maximum case. So that's how from here only, by putting two arbitrary values of theta, rather two specific values of theta. Anti-parallel case में ये हो जाता है, case में ये हो जाता है, and that is the maximum possible value. इससे ज़्यादा हो ही नहीं सकता. Okay, so that's the equality. Okay. Now, finally, one more interesting thing that we get from here is we can now combine our two triangle laws to give us a parallelogram law where within the same diagram we are able to perceive both the things, the sum and the difference. Okay. So what I'm going to do is I'm going to first draw two separate triangles to represent the triangle law for addition. Okay. And the triangle law for difference. Okay. So I'm using the same two vectors in both these. Okay. That is, let's say, this vector E, somewhere here. This vector B, something like this. So I'm making use of these two vectors A and B, but here I have drawn them head to tail like this. So what I've got on this side is the resultant sum of A and B. I've got E plus B. Whereas in the second diagram, the way I've oriented them, you can see that I've not taken A and B. A is there, but I've taken the second one is now minus of B. So this is the vector E, but the second one is negative of this above one. So it's this. So in this diagram, what I'm getting here is this is just what we saw just now. So we already know the formula related to these two triangles and all. So this is A minus B, where typically we label this angle as beta, and over there we label this angle as alpha. Now see what happens a lot of the time in the same problem we want to compare the sum and the difference. So rather than draw two separate geometries, we want to combine these in one. So this is where we'll do something very important. Instead of drawing the two vectors head to tail, I'll take those two vectors A and B which I had. So this was a vector A and this was a vector B. I'll pick up these vectors and draw them from a common origin. Instead of drawing them head to tail, I'll draw them from a common origin. So from some common origin here, I've drawn the vector E and I've drawn the vector B. And now not only these two vectors, I will draw two more vectors. That is one more E, which is like this, and one more B, which is like this, to complete the diagram to get a parallelogram. So if I've drawn this accurately, so as you know, vectors are movable. So if I just shift this vector here, it's still the vector E only. And similarly, if I shift this vector here, it's still the vector B only. So now I have got a what we call a vector parallelogram. Okay. Which has adjacent sides represented by the vector E and B. You can see this and this side are adjacent. This and this side are adjacent. Okay, so now if you look at this thing very carefully, you'll realize what I'm saying. Now just follow my cursor. This is A plus B. So if I just draw this diagonal, now just concentrate on this triangle that we have. This diagonal with these two vectors. Isn't it the sum triangle from above? It's the same triangle as the sum triangle from above. So you realize that this triangle, this one, is basically this triangle. Okay, so I'm just minimizing this for you to understand this. Okay. That instead of drawing, right, so instead of drawing A and B just head to tail in a triangle, if I in fact construct a parallelogram which has two of the parallel sides as A and two of the parallel sides as B, then the primary diagonal of that is becoming nothing but the sum. And this vector triangle is actually contained within the parallelogram. You can see. Now the interesting thing is even the second vector triangle is contained here. If you see this one, that is also contained here. You just draw the second diagonal, this one. The one which is not going from the origin, but which is going from head of one vector to head of another vector. That one is nothing but the difference. Okay. So within the same figure now, you can see that you can also understand that you got the second thing. So again now, follow my cursor carefully and you'll understand what's happening. I want to do the operation of A minus B. So I don't want to do A plus of B. Minus of B is actually pointing like this. So I want to do A, but added with minus of B. So that is this one. So that will become which vector? That will become this vector. So this vector within the same parallelogram now, this represents the difference of the two vectors. Okay. So you can even think of the statement of parallelogram law like a set of steps that we are following. Okay. So I'll just take you through these steps once. Okay. So step one. So given vectors A and B, we want to construct the vector parallelogram. Okay. And from that, we want to find the sum and the difference. The question is, what do we do with it? Okay. So somebody has given me this vector A. Somebody has given me this vector B. Now I want to do this. I want to construct the so-called vector parallelogram so that from that I can get both the things in the same diagram. So this first step that I do is step one, draw vectors A and B from a common origin. Oh, okay. So let's say this is a common origin. So from this point only I'll draw the vector A. So I'll pick up the vector A from above and place it such that it's drawn from this, and I'll pick up the vector B from above and draw it over. So from a common origin, I have sourced vector B also, and I've sourced vector E also. So that's the first step. Okay. Then step two, complete the parallelogram by drawing the other two parallel sides. Okay. So this we can now even do without drawing vectors. We can just draw two parallel sides. So one parallel side like this, another parallel side like this. More or less it looks parallel. So I can even use a dotted line to represent this. So my step one was I picked up the two vectors A and B and drew them both from a common origin, this one. Okay. Then my second step was I completed the parallelogram by drawing the other two parallel sides. Now that's it. Once this is done, the next step is very simple. You first draw what we call the primary diagonal. So primary diagonal is the one from the common origin to the opposite side, and that primary diagonal becomes your sum. Okay, so we'll write this down also. So the diagonal becomes the resultant or the sum. Okay. And the secondary diagonal, so to speak, that we draw, which is from head of one vector to the head of the other vector, that becomes the difference. So each diagonal has a special role to play. So this second diagonal, that becomes A minus B. And in this angle becomes beta. And this triangle above, the two dotted ones with this secondary diagonal, was your vector difference wala triangle. Whereas this triangle below, A with this dotted side and this one, this is your primary vector sum wala triangle. And you can see that both of them are contained in the C. Okay. So step 3 now is for drawing the two vectors, which are the diagonals. draw the diagonals. Okay. Now in the diagonals, the instruction becomes like this. What we label as the primary diagonal that is from origin to opposite vertex, that actually becomes the sum. That's how we remember this, that the primary diagonal is the sum and the so-called secondary diagonal which is from the head of B to the head of E. That diagonal in fact becomes the difference but A minus B. So following these three steps, given any two vectors, we can very easily construct the vector parallelogram and we can take a look at the parallelogram and immediately understand what is the sum and what is the difference. Of course, the formula is the same. Okay, so the sum's formula is the same as what we've seen earlier, that A plus B is root of A square plus B square plus 2AB cos theta, and A minus B has a magnitude of root of A square plus B square minus 2AB cos theta. And here now you can see in this diagram, the angle theta is also much easier to understand because we have drawn it from the common origin. So you can see that the angle theta is nothing but this angle. It is the angle between the vector E and the vector B. So you don't need to look at some exterior angle, which is basically this one here. You can just see that you've drawn the two vectors A and B from the common origin. So this is the angle theta between them. And then this becomes the parallelogram. So this diagonal becomes the sum, this diagonal becomes the difference. And solve it by component algebra. You don't have to draw the triangle, you don't have to do all this. Component algebra is like a universal method that we can use for any and every addition, subtraction, and next lecture we'll see scalar product also, you'll understand. Can be used for any of this. But there are certain very useful things that we get from the geometry. And one of the useful things is by looking at the vector parallelogram, which we construct in this way. And just like I've written the formula for A plus B and A minus B, your tan alpha and tan beta formula are also the same. This is the same formula which you have seen earlier. Tan alpha is B sine theta upon A plus B cos theta. Okay. And tan beta is B sine theta upon A minus B cos theta. So the formula is the same because ultimately, see, this is nothing new. We are getting the parallelogram by in a way combining the two triangles. If we just place the two triangles one against the other, you will see you get the parallelogram. So it's not surprising that the formula is the same. It's just a useful way of expressing it. Okay. So I will just take you a little bit further back, and from there make sure you understand this last point about the vector parallelogram. So these were the two vectors which are given. From that, we constructed the sum triangle and the difference triangle. And we combined the two triangles and that became this parallelogram. Yes, final formula of parallelogram law is the same as the triangle one which I've written beside. That parallelogram law gives you the two formulae in the same one. That mod of A plus B is root of A square plus B square plus 2AB cos theta. And mod of A minus B is root of A square plus B square minus 2AB cos theta. It just gives both the formula for sum and difference within the same figure. Otherwise, there's no difference at all between parallelogram law and triangle law. It's the same statement written in slightly different figure. Instead of the two triangles separately, which I've shown above, we just combine them to make a vector parallelogram. So that is the convenience of the parallelogram law. If somebody said that they solved a problem using parallelogram law and somebody else said by using triangle law, it's no difference. It's one and the same thing. They've used the same thing. Any theta, देखो बेटा, यही you're confusing the thing. See, this is the vector E and this is the vector B. Okay, suppose. So this angle is theta. Na? So now if you construct a vector parallelogram, where that angle will come? It will come at the origin, where you drawn the two vectors like this. This angle will come in here. That was the angle between the two vectors. And this parallelogram will be like this. Whereas if you were using triangle law to add the two things, you would construct them like this. You draw the vector E here, you draw the vector B here. And this angle would be theta. Okay. So it's the same thing. No? You see this and this are the same. Because here, this angle is theta. Okay. So just like in the triangle, now this vector is your A plus B. Now similarly in the parallelogram, this vector is A plus B. You see, this triangle is contained over here. But along with this triangle, there's the second triangle also, the one with the diagonal and EB, and that is this one. So that is the advantage of this. So, you can think of parallelogram law as a combined form of triangle law, part A and part B. Part A was for sum and part B is for difference. There's no difference at all otherwise. And obviously what we're going to apply for the numerical calculation is the formula, and that is the same. Okay, people, so hope my point is clear over here to all of you about parallelogram law. Okay. So this is where we conclude today's lecture. Parallelogram law as a sort of geometrical special theorem that helps us understand more about the the geometry and the visual relationship between vectors. But also keep in mind that any general problem can ultimately be solved by component law. So if geometry is not striking you, if the angle, if the triangle or the parallelogram you are finding it difficult to draw or something, forget about it and just go back to your component method. Okay. But we will see as we do more and more questions for practice that certain types of questions are very easy to work out using geometry, especially using these special theorems that we've discussed today about the geometrical method. Okay. So that's it for today's lecture. Now what will come up in the next lecture is the first thing we'll see is the extension of 2D geometry and components to 3-dimensional components. So next time we will understand how to draw 3-dimensional XYZ Cartesian coordinate frames. And the moment the Z axis is added to X and Y, there will be another unit vector called K cap. And there'll be a slight change in the formula for magnitude of A. It will not involve only AX and AY. Yes, I will be giving you another assignment on today's lecture, and then the next lecture will have. So anyway, so lecture 5, today was lecture 4. So lecture 5 will start with components in 3 dimensions, X, Y, Z components, and we will also discuss dot product or scalar product. So if you're looking ahead in your, from your module you want to read ahead or from some other reference book and all, this is what you can read ahead. But also what is very, very important is today you, after today's lecture, you complete each and every problem of worksheet 3 and make sure you're getting the answer correct yourself. Where you're getting the answer from one method, you can even try out another method and work it out that way. Whatever difficulties, doubts, or even if you're getting the answer but something is not clear in the question or something else came to your mind, something like that also comes to your mind, please drop me a message and I will discuss individually with you whatever difficulties you're having. Achha, in case anything is pending from worksheet 1 and 2, that also make sure you discuss with me and complete within the next 2-3 days, because then you will also have worksheet 4 to solve. And then next week onwards, we will get busy with products also, with scalar product also. So some difference, whether you are doing by geometry method or by, by this method, component method, you have to now, work hard on this and make sure everything is clear by next lecture, so that, after next lecture, you can start concentrating on the new part, which will be doing, which will be the product. Okay. So that's it from me guys today. Hope you have enjoyed the lecture and you're understanding more about vectors day in, day out. Okay. if anything, any part you're having difficulty, don't hesitate to discuss with me. It happens. Vectors is a bit complicated initially, so doubts are bound to come to your mind. Okay? Just because doubts are coming doesn't mean that you're not studying enough or anything. You just need to clear the doubts. Okay. So that's it. And until next time, all the best. Stay safe and help your parents at home. That's it.